All right, we're being asked to consider the number 9056.1437. Said another way, 9056 and 1437 ten-thousandths. The question has four parts, A, B, C, and D, but we will focus our attention just first of all on part A, which asks, which digit is in the hundreds place? So because it ends in a DS, we are looking for something that is to the left of the decimal point. So let's just review what these place values are named. Okay. The first place value is the ones, then the tens, then the hundreds, and then the thousands. Lining up the number which I have been given, we can answer the question, which digit is in the hundreds place? The answer to this question is 0. 0 is in the hundreds place. And we can go on to part B. Which digit is in the hundredths place? Well, now this ends in DTHS, so we are looking for something to the right of the decimal point. Let's review what the names of these place values are called. The first place value to the right of the decimal is the tenths place, followed by the hundredths, the thousandths, and the ten-thousandths. Lining up the decimal which I have been given, we can answer the question, which digit is in the hundredths place? The answer to this question would be 4. 4 is in the hundredths place. And we can go on to the next question, which says, what is the place value of the digit 5? The 5 is to the left of the decimal place. So again, let's review these place values, which are the ones, the tens, the hundreds, and the thousands. Lining up the decimal which I have been given, what is the place value of the 5? The place value of the 5 is the tens place. The tens place. And we can go on to part D. Name the place value of the 7. The 7 is to the right of the decimal point. So we'll again review these place values, their names. The first is the tenths, followed by the hundredths, the thousandths, and the ten-thousandths. Lining up the decimal which I have been given, name the place value of the digit 7. We would answer the ten-thousandths. And that is the end of this question. Okay, we're being asked to consider the number 35,467 and 2,901 10,000ths. Said another way, 35,467.2901. There are 4 parts to this question, A, B, C, and D, but we'll focus our attention first of all on part A, which asks which digit is in the ones place. We're being asked about something that is to the left of the decimal point, so let's just review the names of all of these place values. We have the ones, we have the tens, we have the hundreds, the thousands, and the 10,000s. Lining up the number which I have been given, which digit is in the ones place? We would answer 7. Moving on to part B, which digit is in the tenths place? Since it ends with THS, we're being asked about something that is to the right of the decimal point. So let's just review these place value names. The first place value to the right of the decimal point is our tenths, followed by the hundredths, the thousandths, and the 10,000ths. Lining up the number which I have been given, which digit is in the tenths place? We would answer 2. The 2 is in the tenths place. And we can move on to part C. Name the place value of the digit 5. Now, the 5 is to the left of the decimal point. So let's review these place value names again. They were the ones, tens, hundreds, thousands, and 10,000s. Lining up the number which I have, we can answer the question, name the place value of the digit 5. Well, the 5 is in the thousands place. And we'll move on to part D of this question. Now, part D asks us to name the place value of the 0. The 0 is to the right of the decimal point. So let's review these place value names again. The first were the tenths, followed by the hundredths, then the thousandths, and the 10,000ths. We'll line up our number. So name the place value of the digit 0. Our digit 0 is in the thousandths place. And that is the end of this question. Compare the decimal numbers by filling in the blank with less than, greater than, or equal to. On the left, we have the number 792 10,000ths. On the right, we have the number 79 thousandths. But which is greater? In order to compare, I'm going to add a 0 to this number on the right so that both numbers have 4 digits to the right of the decimal point. Remember that adding a 0 to the right of a decimal point at the end does not change the place value of a number. Now, in order to compare, I'm going to start from the left and compare places until I find the number which has a larger digit in the same place. So I'll start with the ones place. Both numbers have a 0 in the ones place, so I move to the right. And again, the numbers match. In the tenths place, they both have a 0. In the hundredths place, both numbers have a 7. In the thousandths place, both numbers have a 9. It's not until I get to the 10,000ths place that I see a difference. And because 2 is greater than 0, we know that this number on the left is greater than the number on the right. Compare the decimal numbers by filling in the blank with less than, greater than, or equal to. On the left, we have 10 and 601 thousandths. On the right, we have 10 and 61 hundredths. But which is greater? To compare, I'm first going to give them the same number of places after the decimal point. So I'm going to add a 0 to the right of this number on the right. Now they both have 3 digits to the right of the decimal point. To compare, I start all the way from the left, comparing each place until I find where the numbers differ. So I'll start with the tens. Both numbers have a 1. I move to the ones. Both numbers have a 0. To the right of the decimal point, in the tenths place, still the numbers match. Both numbers have a 6. When I get to the hundredths place, I see a difference. And because 0 is less than 1, this number on the left is less than the number on the right. Write the decimal numbers in order from least to greatest. The first thing that I am going to do is to add zeros to the end of these decimal numbers so that they each have 4 digits after their decimal point. Remember, adding zeros to the right of a decimal point after all of the non-zero digits does not change its value. Now I'm going to compare these numbers place by place. Notice all 3 numbers have a 0 in the ones position, and all 3 numbers have a 5 in the tenths position. It's not until I'm comparing the hundredths place that I notice a difference in these numbers. And because 0 is less than 7, this number is the smallest, and I'll start by writing 0.5. And I've taken care of this one. I continue by comparing the other 2 numbers, and I move on to the hundredths place, in which case I see that 2 and 1 are in the hundredths place of these 2 numbers. And since 1 is less than 2, this decimal 0.5719 is smaller than our third 0.5720. A grocery store sells bananas in bags, with each bag containing approximately 2 pounds of bananas. Find the median weight for the 7 bags if their actual weights are listed here. We need to compare these 7 numbers and put them in order from least to greatest. By comparing the ones place, we see that 3 of the numbers have a 1 in their ones place. These are the smallest 3. Continuing to compare these numbers place by place, I begin by giving them all 3 digits after the decimal point. In the 10th place, they all have a 9. In the 100th place, I see these 2 are the smallest because they have an 8 in their 100th place, whereas the other number, which I have underlined, has a 9 in its 100th place. So these 2 are the smallest 2, and also because 0 is less than 7, I know that 1.98 is the smallest of these numbers, and that 1.987 comes second, and that the other number beginning with a 1, 1.999, comes third. Continuing to put the other 4 numbers in order from least to greatest, I'm going to give each of these 3 digits after their decimal point and compare place by place. I see that from these ones, now I'm only working with the circled numbers here, out of these 4 circled numbers, 3 of them have a 0 in the 10th place. So these ones will come first. Okay. If we go on to the 100th place, we see that these 2 have a 1 in their 100th place, which is less than 5, and that since 0 is less than 3, the next smallest number is 2.01, followed by 2.013, followed by 2.05. The largest in our list is 2.1 because it's the only of our numbers that has a leading digit in the ones place of 2 and a 1 in the tens place. So I've ordered my numbers from least to greatest. Since I have an odd number of numbers in my list, I have 7. We know that we have one middle number, and that middle number is 2.01. 2.01 is the median. Estimate 1,234. To estimate, we use the leftmost non-zero digit, which is the 1, and we look immediately to the place on its right, which is the 2. And since 2 is less than 5, we keep the 1 as a 1 in the thousandths place, but we convert all of the other digits to 0. So the estimate of 1,234 is 1,000. Estimate 37.5. I use the leftmost non-zero digit, which is 3, and I look immediately to the place on the right, which is a 7. because 7 is larger than 5, I'm going to round my 3 up to a 4, but keep it in the tens place. Everything after that becomes a 0. We don't need any of the decimals. So to round to 37.5, our answer is 40. Estimate 961. In order to estimate, we use the leading digit, which is the 9, and we also look next door to the 6. Because 6 is greater than 5, we want to round the 9 up to a 10. The 1 actually carries to the thousands place, and we keep a 0 in the hundreds place. Everything after that is converted to zeros. So the estimate of 961 is 1,000. Estimate 649 10,000ths. We use the first non-zero digit, which is 6, and we also look next door to the 4. Because 4 is less than 5, we keep the 6 as a 6 in the hundredths place. But we do not use any of the digits after that. So our estimate becomes 0.06 or 6 hundredths. Round 523.4187 to the nearest tenth. The 4 is in the tenths place. To round, look next door to the right where we have a 1. Because 1 is less than 5, the 4 remains unchanged, and the answer is 523.4. Round 12,345 to the nearest 10. In the tens place, we have a 4. In order to determine how to round, we look to the right, where we see the next digit is a 5. Because we have 5 or greater, we round the 4 up to a 5, and then everything behind that becomes a 0. So the answer to my problem is 12,350. Round 5.698 to the nearest hundredth. For this number, we have a 9 in the hundredths place. In order to round, we look to the right, where we have an 8 as the next digit. Because this 8 is 5 or greater, it's going to round our 9 up to a 10. The 1 from the 10 gets carried to make my answer 5.70. Round 5,349.8162 to 3 decimal places. 3 decimal places over would be our thousandths place, in which we have a 6. In order to determine how to round, we look to the next digit on the right, which is a 2. And since this 2 is less than 5, we keep the 6 as a 6, but end or decimal number there. So the answer to this question is 5,349.816. Round 8.597 to 2 decimal places. 2 decimal places over is the hundredths place, in which we have a 9. In order to determine how to round, we look to the next digit on the right, which is a 7. And because 7 is 5 or greater, the 9 will round up to the 10. The 1 from the 10 gets carried to make the tens digit a 6. We truncate our decimal after 2 decimal places, so we end at the hundredths place, and my answer is 8.60.